Sing and learn through songs.
Play and sing, learn everything with ease.
See and hear, remember forever with ease.
Let the flowers of knowledge bloom in our hearts.
Let us move ahead and become the best. Sing and learn through songs. Near a wire where current flows, a mighty hidden power grows. Though our eyes may never see, a magnetic world spreads silently. Can electricity become a magnet? Shall we learn the secret behind it? Sing and learn, come find it out. Open the magnetic world all around. First question, listen carefully. What is a magnetic field? Around a magnet or around a conductor carrying electric current, where magnetic effects can be felt. That region is a magnetic field. Magnetic field lines help us know its direction and its strength. This invisible magnetic world, let us keep it clear in our minds. Second question, let us hear what happens around a straight wire carrying electric current. When electric current flows through a wire, a magnetic field is formed around the wire. With it at the center, field lines appear as circles. One circle line inside another, concentric circles all around. As the electric current increases, the magnetic field grows stronger too. Third question, what did Ørsted's experiment teach us? Near a wire carrying electric current, he placed a magnetic compass needle. The needle suddenly changed its direction. Ørsted watched in amazement. The moment the current was switched off, the needle returned to its old position. This proved that electric current produces a magnetic field. This is the lesson Ørsted gave us. Electricity and magnetism are closely linked together in a strong and inseparable bond. Fourth question, what are the main properties of magnetic field lines? They are imaginary lines we use to represent a magnetic field. At every point, the direction of a field line shows the direction of the magnetic field. Where the lines are closer together, the magnetic field is stronger. And two magnetic field lines never cross one another. When electric current flows, a magnetic field forms. Ørsted showed this clearly to us. Circular magnetic field lines dance around the current carrying wire. Can electricity become a magnet? Do you understand the secret now? When we sing and learn our physics, it will shine forever in our minds. Shall we find the next secret now? Let us learn how directions can change when a wire and a coil work together. How does magnetic strength increase? Fifth question, listen carefully. If the direction of electric current changes, what happens to the magnetic field? If the current direction is reversed, the magnetic field direction reverses too. The moment the current changes direction, the field direction becomes opposite. Current and magnetic field have a relationship. Remember it well. Change the direction of one and the direction of the other changes too. Sixth question, pay attention. What is the right hand thumb rule? Hold a straight wire with your right hand. Keep your thumb pointing straight. The direction in which your thumb points is the direction of electric current. The direction in which your other fingers curl shows the direction of the magnetic field lines. The right hand thumb rule is our friend for finding direction. Seventh question, listen now. What happens when electric current flows through a circular coil? Around every part of the coil, a magnetic field is produced at the center of the coil. These fields join in the same direction, so the field becomes stronger at the center, and the magnetic effect increases. Increase the number of turns, increase the current, the field gets stronger. Now listen to the final question. What is an electromagnet? How can we increase its strength? The magnet produced with the help of electric current is an electromagnet. Inside the coil of wire we can place a soft iron core. Increase the number of turns and the magnetic strength will increase. Increase the electric current too, and even more strength can be obtained at a soft iron core inside, and the magnetic effect grows stronger. That is the simple secret behind an electromagnet. When electric current flows, a magnetic field forms. Ørsted taught this clearly to us. The right hand rule shows the direction. The circular coil makes the field stronger. Increase the turns, increase the current at a soft iron core inside. From electricity we can make a magnet and see the magic of science come alive. Can electricity become a magnet? Yes, now we know the answer. All this knowledge learned through song will stay with us in every exam.
Dear children, through today's learning song, we understood very easily about the magnetic field, the magnetic effect around a current-carrying wire, Ørsted's experiment, magnetic field lines, the right-hand thumb rule, a circular coil, and the electromagnet. Now, let us once again recall the 8 questions and answers in the same order in which we learned them through the song. First question. What is a magnetic field? Answer. The region around a magnet or a current-carrying conductor where a magnetic effect can be experienced is called a magnetic field. Magnetic field lines help us understand the direction and strength of a magnetic field. Second question. What happens around a straight wire carrying electric current? Answer. When electric current flows through a straight wire, a magnetic field is produced around it. The magnetic field lines around the wire appear as concentric circles with the wire at the center. As the amount of electric current increases, the strength of the magnetic field also increases. Third question. What did Ørsted's experiment teach us? Answer. Hans Christian Ørsted observed that when a magnetic compass needle was placed near a current-carrying wire, the needle was deflected. When the electric current was switched off, the magnetic needle returned to its original position. This proved that electric current produces a magnetic field. In other words, electricity and magnetism are closely related. Fourth question. What are the main properties of magnetic field lines? Answer. The imaginary lines used to represent a magnetic field are called magnetic field lines. The direction of a field line at any point indicates the direction of the magnetic field at that point. Where the field lines are closer together, the magnetic field is stronger. Two magnetic field lines never cross each other. Fifth question. What happens to the magnetic field when the direction of electric current is changed? Answer. When the direction of electric current is reversed, the direction of the magnetic field around it also reverses. Therefore, there is a definite relationship between the direction of electric current and the direction of the magnetic field. Sixth question. What is the right-hand thumb rule? Answer. Imagine holding a straight current-carrying conductor in your right hand. If the extended thumb points in the direction of electric current, the direction in which the other fingers curl around the conductor shows the direction of the magnetic field lines. This is called the right-hand thumb rule. Seventh question. What happens when electric current flows through a circular coil? Answer. A magnetic field is produced around every part of a circular current-carrying coil. At the center of the coil, these magnetic fields combine in the same direction to produce a stronger magnetic field. The strength of the magnetic field increases when the number of turns in the coil is increased or when the amount of electric current is increased. Eighth question. What is an electromagnet? How can its strength be increased? Answer. A magnet that acquires magnetic properties with the help of electric current is called an electromagnet. A strong electromagnet can be made by placing a soft iron core inside a coil of wire and passing electric current through the coil. To increase the strength of an electromagnet. 1. Increase the number of turns in the coil. 2. Increase the amount of electric current flowing through the coil. 3. Use a suitable soft iron core inside the coil. Children. So, through today's learning song, we understood that a magnetic field is produced when electric current flows. The right-hand thumb rule helps us find its direction. The magnetic strength can be increased using a coil, and an electromagnet can also be made with the help of electric current. To get learning songs like this in all subjects and in the language of your choice, you can join the Paadi Padikkam group. To join the group, first scan the QR code now shown on the screen. When you scan the QR code, you will receive the link to join the Paadi Padikkam group. Scan this QR code right now. Watch the free sample lessons. Then you can also join the Paadi Padikkam group. For those who are unable to scan the QR code, there is another option. If you are interested in becoming a member, simply send a WhatsApp message to 813-807-3227 with your name, your preferred language, and the word sample. You will receive the link to watch and listen to 3 free sample learning songs, along with the membership link. With this, today's learning journey comes to an end. We will meet again in the next learning song. Thank you. Namaste. I am your own Ivan. From Paadi Padikkam.
Sing and learn 3 sounds.
Play and sing, learn everything with ease.
See and hear, remember forever with ease.
Let the flowers of knowledge bloom in our hearts.
Let us move ahead and become the best. Sing and learn